Hello folks, this is Jeffrey Bale. My call sign's NT1K. And today I went to a Hamfest and someone has graciously gave me one of these things. What this is a low-pass filter, because it says so right here on the label. What a low-pass filter does is it allows the lower frequencies to pass through the filter while attenuating or blocking, so to speak, signals that are higher. Hence it allows the low to pass and blocks or attenuates the high signals. Back in the day when TV was being transmitted on VHF, you had a lot of people in your neighborhood with VHF TVs, or TVs that could receive VHF and the antennas, and there's a possibility that your station could interfere with those TVs, and you would have some upset neighbors. So installing one of these would help in that situation. It would make your neighbors a little happier. So, but TV has has since upgraded, and we're now on digital TV, and a lot of it's on UHF, or actually all of it I think is on UHF. So there's a lot of people out there that feel that these filters are no longer necessary, but there are still uses for these. For example, if you have neighbors that listen to FM radio, I have one. He likes to listen to a lot of FM and AM broadcasts, and you're interfering or your signal's showing up on his radio, that would help. And another situation where a low-pass filter would help out is if you're living in an area that has a lot of high-powered broadcast equipment, like you live right next to an FM radio station or something like that. So this would help out quite a bit. I'm not sure if this works even. I wasn't sure if this completely works. It looks nice. It looks like it's been taken care of. There's no dings or huge scratches. It appears to be made out of 080 aluminum. It's probably been chem filmed or yellow iridized probably. And you can see that the filter has 3 compartments, because you got these spot welded, these little spot welds. So it tells me that there's 3 compartments, and the 3 screws give it away. So I wanted to get inside of it, but it's been riveted shut. I could drill the rivets and gain access to the case, but I didn't want to go that far. So a way to test out to make sure this actually works is with actually a handy device I just picked up. This is called it's right here. It's called the MiniVNA PRO by Mini Radio Solutions. I'm not a skilled person on test equipment, and I bought this basically as an antenna analyzer. Make sure the antennas I build or assembled are actually in working order. So this is a sort of new to me, and it's great to learn a lot. So I've used this to test this, and we'll see what happens. So what we're gonna do with the MiniVNA is we're gonna hook up the MiniVNA to the filter by hooking it to this jack here. We're gonna inject a signal through the filter. It's gonna come out the other side, and the signal's gonna go back into the VNA, the MiniVNA, where it will analyze the loss in dB and tell us what's happening here. So I got some connectors here. These are really not the most appropriate and best connectors here to use, but it will give me an idea whether or not this filter is working or something is shorted out or whatnot. So I'm going to hook up hook this up here. Little SMA connectors. I read the reviews on the MiniVNA before I bought it, and some people had trouble installing and running the VNA, but I had no issues so far. I got it to run on Windows 7. I got it to run on Windows 8, both 64-bit systems. I had them running no problem. My advice is to, before you hook this up to your computer, to go to the Prolific website and download their latest drivers and install them before you even attempt to hook this up to your computer through the USB cable. So I'm going to hook up now the cable to the other side here, and now we got our loop. Alrighty. Let's hook that up. So now we got the transmission coming out of the MiniVNA, in through the filter, out the coax, back into the MiniVNA. So I got my laptop. Laptop here running the latest software, MiniVNA J. I mean not MiniVNA, VNA J. I'm sorry. And we're gonna take a sample right now. I know you can't really see the screen, but I will change that. We're gonna go into transmission mode, and we're gonna start our frequency at 100 kilohertz, and we're gonna end our frequency at around 60 megahertz, because I don't need to go all the way to the 200 megahertz that the MiniVNA can do. So we're gonna do a single pass with the. It's gonna sample 2000, and there's some lines. Let me get the screen here better. Excuse me. Okay. What you see here is two things in transmission mode. You got loss. This is the green line right here that I'm following, and then you have the phase. Now I'm not 100% sure what the phase is just yet, but I see the loss, and if you see that by my marker here, let me get a see if I can get a brighter color here. Yeah. With the marker here, you'll see that there's a nice solid line, and all of a sudden it takes a big dip. And if we look at our graphs here, on the left side here, we got dB from 0 to -90 dB, and then on this scale we have frequency, which is from 100 kilohertz all the way up to the 60 megahertz mark. I will post a copy of this photo on NT1K along with a nice little article about the MiniVNA. But if we start measuring this line here, you'll see that there's barely any, whoops, if I put my crosshairs here, that there's barely any loss as we're going along. So we're at 3 megahertz right now, or here we are, 3.4 megahertz. And you'll notice that there's 0.67 dB of loss. And it remains that way up until 37 megahertz. That's when we start to see more loss. And then all of a sudden, right around 38 megahertz, it starts taking a dive, and there's more loss, more dB. So at 40 megahertz, we're at 12 dBs. As we keep going along, we're at 43 megahertz, we're at 30 dB. If we keep going down, and instead the box did say 80 dB at 41 megahertz. So if we went to 41 megahertz, there's only 13 dB. But if you get down to 51 megahertz, 52 megahertz, I am seeing the 80 dB that they're calling out for, and it plateaus around, it evens out at 80 around 52 megahertz. So this tells me that this filter actually works, and it's doing its job, still doing its job. So it's a great way to, the MiniVNA Pro is a great way to test things like this, and I'm learning a lot. I wish I could learn more, but this was pretty neat, and hopefully I can get a high pass filter to get rid of the AM broadcasting AM broadcast stations that are near my house. Hopefully I get to make one of those, and when I do get to make one of those, I will be able to use this MiniVNA to measure the filter to make sure it will notch out those or get rid of those AM broadcast stations. So thank you for watching, and hopefully this helps you out. As I said, I got to install no problem. There's a lot of reviews about the MiniVNA or Pro or the regular one not installing. I'm not sure, but I'm using, as of February of 2014, I'm using the latest software, and I had absolutely zero issues with this unit so far, so I'm enjoying it very much. My suggestion, someone suggested to me that if you do happen to buy one of these, to attach these little port savers, because you can only, these little port savers right here, whereas they're like these little guys right here. People suggested that I attach these, just that way when you keep screwing and unscrewing the SMA, you're not ruining the connector that's secured to the board of the MiniVNA. And since this is directly attached to the board, I would also suggest not putting any kind of torque or strain onto the connectors themselves. That way you don't risk ruining the board or detaching the SMA to the board, or breaking the board actually. So once again, thank you for watching, and I will post a screenshot of this on nt1k.com.